FreeCAD versus SolidWorks. One is completely open source and free. The other is one of the most established professional CAD platforms in the industry. But here's the real question. Can FreeCAD actually compete with SolidWorks? And more importantly, which one should you learn in 2026? Today, we're going to compare them in modeling, assemblies, drawings, simulation, CAM, performance, ease of use and, of course, price. Let's find out. Let's start with the biggest difference. FreeCAD is open source software. You can download and use it without paying for a commercial CAD license. That makes FreeCAD extremely attractive for students, hobbyists, makers and engineers working with a limited budget. SolidWorks, on the other hand, is a commercial professional CAD platform with subscription-based offerings. So if your first question is, which one can I start using without buying a commercial CAD license? FreeCAD wins this round, but price isn't everything. Let's move to actual design work. Both programs use parametric modeling. You can create sketches, apply dimensions and constraints, then turn those sketches into 3D features. In FreeCAD, you can use the part design workbench to create features such as pads, pockets, fillets and chamfers. SolidWorks follows a similar feature-based approach. So for normal mechanical parts, both can get the job done. But the user experience is different. SolidWorks generally provides a highly polished, integrated workflow designed around professional product development. FreeCAD gives you something different: freedom. Its workbench-based system allows you to move between different types of CAD, engineering and manufacturing workflows. And that's one of FreeCAD's biggest strengths. Sketching is the foundation of parametric CAD. In both programs, you can create geometry and control it using dimensions and constraints. FreeCAD's Sketcher includes a constraint solver, allowing you to build fully constrained parametric sketches. SolidWorks also has a mature sketching environment designed for fast mechanical design. For beginners, both require some learning. But once you understand constraints, you stop thinking about drawing lines. You start thinking about design intent. And that's the real power of parametric CAD. Now let's talk assemblies. SolidWorks is extremely well known for assembly-based product design. You can bring components together, apply mates and build complex mechanical products. FreeCAD has also made major progress here. FreeCAD 1.0 introduced a built-in assembly workbench, while additional community workbenches provide alternative assembly workflows. So FreeCAD is no longer simply a single-part modeling program. For basic and many intermediate assembly projects, FreeCAD can be a very capable option. But for large, complex professional assemblies and highly standardized commercial workflows, SolidWorks still has a major advantage. Engineering isn't finished when the 3D model is complete. You need drawings, dimensions, sections, annotations, and manufacturing information. FreeCAD can create 2D technical drawings from your 3D models. SolidWorks also provides a mature drawing environment designed for production documentation. For students and general engineering projects, FreeCAD can absolutely handle the job. But in a professional company environment, SolidWorks has a very established ecosystem and workflow.